Welcome to Chapter 5, Measurement, Section 5.1. This is the second part of this section, working with measurement numbers. And we're going to look at the following objectives: how to add and subtract measurement numbers, and how to multiply and divide measurement numbers, and their associated units. So we're going to be looking at numbers that we get after we measure things. Looking at addition and subtraction of measurement numbers, one of the things that you really want to make sure that you follow the rule that the resulting answer can't be more precise than the least precise measurement that you're using. So think of this as you won't have a final answer that's more than the weakest link of the problem. And so you're going to use the following rule. You always round a sum, which is from addition, or a difference, which is from subtraction, to agree with the precision of the least precise measurement that's being added or subtracted. One of the things that is implied in this, but not specifically stated, so I want to make sure to point out, is that you always round the sum or the difference, and you don't round the individual numbers that you're adding or subtracting first. So make sure you get to the sum or the difference and then do your rounding. So let's look at an example. 4.6 gallons plus 2.145 gallons equals 6.745 gallons. And that is a precise answer to that problem, except for 4.6 gallons is our smallest precision because it has two significant values, and it's precise only to 1/10, and so that's why we want to say that we'll round to the nearest tenth after we have already added the whole problem up and we have our sum. The squiggly little line that looks like an equal sign means approximately equal to. And so looking at the next problem, go ahead and pause the video if you'd like to go ahead and try this one on your own first. And they give you the answer right there, and so hopefully you've reasoned why that is the right answer to be able to find out what the precision is. So you're rounding the answer to the nearest hundredth to agree with the fact that 0.24 miles is the least precise value. I'll go ahead and look at this one and figure out the reason why. So you probably saw, or when you did this problem, that 2,473 pounds was the least precise measurement, and that's the reason why the answer is about 2,794 pounds after you add it and then round it. All right, let's go ahead then and look at multiplication and division of measurement numbers. It's going to be a little bit different here. Multiplication and division differs when you're looking at not only the correct rounding of the final answer, just like you would with addition and subtraction. So when you're looking at the product from multiplication, or the quotient from a division problem, but with multiplication and division, the units also, you need to make sure you really look at the units and pay precise attention to the units as well, because in addition and subtraction, your units carry over. If you're adding miles, then you get miles. If you're adding pounds, your answer is going to be in pounds. But that's not the same in multiplication and division. So to look at an example, if I am talking about multiplying 3 feet by 2 feet, first I'm going to look at 3 feet, or 3 times 2 is 6, and I'm only looking at the number. And then second, I'm going to look at the units. So in this case, feet times feet gives me feet squared, or 1 square foot. And so the answer is really twofold. I have 6 feet squared, or 6 square feet, which describes not a linear measurement of feet, but it describes the area. So think about if you're going to put a rug in, you would measure that. The number of feet of one wall, the number of feet of another wall, the area that you're going to put the rug on is measured in feet squared. We'll look at another example here where we're multiplying three numbers, so 2 inches by 3 inches by 5 inches. We're going to again do this separately. We're going to multiply 2 times 3, which is 6, times 5, which is 30, and then we'll multiply the units, which is inches by inches by inches, or cubic inches, and this actually measures volume. And so 30 cubic inches measures volume. Those of you who are in the medical industry will be very familiar probably with cubic centimeters in measuring volume. So a centimeter times a centimeter times a centimeter. So if you're looking at units and trying to visualize units, to me this is very helpful, and it also describes a little bit about why we have the nomenclature that we do. If we're looking at the very first one up here, and we're going to measure length. Length is measured in this case, an inch. It's a linear measurement from here to here, and that is, if you add an inch to an inch to an inch, then you have inches. And it is only one measurement, and so we say it's one dimensional. Now, if we look at the area, it is 1 inch by 1 inch, so we're measuring two different things. That is something that is two-dimensional, and it measures area. And then if we're looking at something that we want to say is three-dimensional, so imagine you can hold a block in your hand. This is a two-dimensional representation down here of a three-dimensional object, and it has three different sides that we multiply together, and we call it, and it measures volume, so you can actually pour stuff in here and it would hold it, and it is measured by cubic inches because it is a three-dimensional object. So hopefully that helps you remember on whether or not you should use a, if it is in meters, and is it, oh gosh, is that meters squared? Is that meters cubed? Well, meters squared looks like a square, and that would be m squared, or meters cubed looks like a cube, and it is meters cubed. So hopefully that helps you remember. Okay. So we're going to look at a real-world problem here. Notice that the way that they split this out is going to be really important, and the way that they do the division across is really important, because this is how we're going to do some of the unity problems in the next section. So first off, what you want to do is you want to divide the numerical parts. In this case, we're going to divide 24 by 1.5, and that gives you 16. And then you're going to divide miles per hour, and so this is miles and this is hour, and so that's our units, and it looks like this, miles per hour. Notice we do it separately, so 16 miles per hour. And the way that this problem is set up is set up as a division problem. Same thing as up here, except for doing it this way, and this is going to be very helpful, like I said later on. 24 divided by 1.5, and then it is going to be multiplied to get our units of miles per hour. So we multiply straight across, 24 miles times 1.5 hour, do the math separately, 16 by 1 mile per hour. Notice that this is a term that's all together. It took our miles per hour and gave us what they call a compound unit, or more, you'll also find this called a derived unit. So to multiply miles per hour times another value, we're going to do the same thing. We're just going to multiply the values, 45 times 4, and then miles per hour times hour. So notice on this one right here, it's miles per hour, per being a mathematical term we know, and it means division, so miles per hour, miles divided by hour, times the hour. Now, why did they put the hour up here and not, say, like, hour under here? Well, the reason why is because just a second. The reason why is because, remember, everything, if it's just by itself, if it's a number, if it's a value, is over 1, because that makes it a whole number or a whole value. So in this case, this is miles per hour times the hour, or the way that they have it here is just by the hour. And then so in this case we'll cancel the hour, because hour divided by hour leaves us just the number 1, because they cancel each other out, and we end up with miles, and that is what we end up with right here after we get 45 times 4. Okay, this is, like I said, that's going to be really useful for when we are working in the next section. And so let's look at this example then. If we want to divide square yards by yards, again, we'll take 42 divided by 6. We'll take our square yards, divide them by yards. The yards cancel out, and we end up with just yards. So, because square yards is, in this case, remember, square yards back here is yards times yards, and that's the same thing. So, all right, so we will move on to the next section. Make sure to rewind this if you have any questions and you get a good grasp and concept of it.